Um, Welcome once again to my YouTube channel. We're continuing on the study of microeconomics. Today, the topic is models in microeconomics.
So, in the course of this study, you are going to be learning the meaning of models. You're going to be learning the types of models. You are going to be learning the processes of modeling. And you are going to be learning the uses of models. Uses of what? Models. So, by the end of this lecture, you are expected to learn or to have understand the concept of model in economics generally. You are expected to be able to identify the various types of models and explain the processes involved in forming models and the uses of models. And the uses of what? Models. So let's go to the meaning of models. Let's go to the meaning of what? Models. Of course, just like every other concept, model has been conceptualized in various ways. Just like every other concept, model has been defined differently uh, by many scholars, but each of these definitions will be arriving at a particular or are similar, just the languages used that differs. But let's look at this. A model is referred to as the simplification of what? Complex reality using mathematical notation. The simplification of complex realities using mathematical notations. In our previous class, we talked about how microeconomics is important in model building, and I tried to explain to you how the complex issues such as various factors determining demand can be simplified in a simple model. In a simple model. Those who have watched the lecture will see how a simple qx equal to f, how qs equal to fx, equal to fpx, uh, py, r, I, and so on, is used to simplify the various factors we have mentioned to be affecting demand. So, why is models simplifying complex reality? It is because this complex reality, they are difficult to explain sometimes. They are ambiguous sometimes. Sometimes when you look at it, they tend to be um too large, you know, because of the various uh, items that is involved. So, in order to make this very easy, a simple, mathematical notations, we just make it, just you may not even have to write plenty, even in your book when you are trying to explain it. You just say Q is a function of P, and you have said so many things that if you want to write, you have to write it maybe half a page. This is what it is saying. This is what it is saying. So in economics, a model is a theoretical construct that represents economic processes by a set of variables. By a set of what? Variables. Like in the case of that um, demand, uh, factors that determine demand. By a set of variables, we are able to represent um, price of the commodity with just P or and px. We're able to represent price of related commodity or other commodities with py. Then we are representing We represented income with I, and so on, where quantity demand itself was represented by QX. So these are the method. So these uh, variables that are represented, these economic processes that are represented by variables is set to logical to have a logical and quantitative relationship. They will design in such a way that you will now understand the kind of relationship that exists between them through mathematical relationship, mathematical denotations or notations. You understand. For instance, you can establish in that factors affecting demand. It's represented in such a way that it's a linear relationship. That as this one, you know, uh, now this it has a direct effect on the variables. There is a dependent variable. There is an independent variable. That the independent variables have this effect on the dependent variable. Now, sometimes it will be a negative relationship. At other times, it will be a positive relationship. You understand? So, in other words, a model is an economic theory that simply explains related, how factors are related using mathematical or even graphical forms and notations. How factors are related, how price affect quantity demanded. What kind of um, effect is that? When you look at the way price affect quantity demanded, you will okay, it's a kind of inverse relationship. As the price is going up, quantity demanded will be going down. Now, this is the theory, this is the theoretical statement. Then, for what is his name? For income, in another instance, for income, as income is going higher, quantity demanded will likely go higher. You understand now? So this is a positive relationship. This is a positive what? Relationship. This is a positive relationship. So these are the kind of things we are talking about. These are the kind of this is how model assist in mathematical concept. The example here is the examples we have given before, but just using a single variate form. We said the quantity demanded of a commodity X is a function of price of commodity X. This is the theory. Now, to represent this long grammar, to represent this long grammatical relationship, you just say QD equal to F open bracket P close bracket. It's not even up to one line. It's not even up to one line to write that down. So if you want to expand such a function, you can expand it in such a way that it looks like QD equal to alpha minus beta P or beta P. QD, the D is superscript. Q like raised to power D. The QD is superscript. You understand? So you say QD equal to alpha minus beta P. This alpha and beta are constant, are parameters used in establishing this relationship. You understand? You can use A and B. You can use C and D. You are the one that will define it so that everybody will understand. So QD represents quantity demanded. P is price of the commodity, while alpha and beta are parameters. What alpha stands for is that quantity demanded will be equal to alpha when the price is zero. For instance, when there is no price charged on the commodity at all, then the quantity demanded of that commodity will be equal to alpha. Now, it can be any amount. Are you with me now? It can be any amount. While the beta part, the beta, which is the coefficient of price, shows the rate at which price, the rate of change between price and quantity demanded. It is like the percentage, how the percentage of change in quantity demanded is measured in relation to price. For instance, price increases from price of what is it called? Price of data increased from 100 naira for 100 MB to 200 naira to 100 MB. Now, what is the percentage change in price? By what proportion will that increase affect your quantity demand, your demand for data? Will you now still be buying 100 how many MB you used to buy? Before, when it was 100 MB to 100 naira, you used to buy 10, you used to buy 1000 naira, which is probably 10, 1000 gig, 1000 MB. But now that it is 200 to 100 MB, if you want to continue buying 1000 MB, it means that you have to be spending 2000 naira. But if it affects you the way the theory says, which is a negative effect, you are going to reduce your quantity demand of data by reducing to maybe 500 naira. But what proportion, by what is the proportion of the reduction? That is what better measures the rate at which you reduce. Is it very high or very low? Some people will drop to 800 MB, some will drop to 300 MB, some will drop to 500 MB, some will drop to 900 MB, some will drop to 400 MB, and so on. Now, these are different proportions. So, which means your beta, the value beta will assume at the end of the day, will differ from person to person, individual to individual. So, but when you look at this illustration, between of quantity demand and price, there are two things you will notice there. One, there are two major variables. The two major variables are quantity demanded and price. QD and P, they are the two major variables. QD and P are the two major variables. So, the quantity demanded was represented by QD, while price was represented by what? P. One of them is a dependent variable, while the other is an independent variable. Now, economic models are designed to establish relationships. In this relationship, some variables are depending on what happened to other variables. Some variables depend on what happened to other variables. Other variables affect some variables. Now, when a variable will remain as it is, if some variables will remain as it is if nothing happens to other variables, then we call such a variable a dependent variable. A dependent variable. Now, those other variables that affect this dependent variable, that if something happened to them, there will be a change in the dependent variable. These variables are called independent variables. These dependent variable and independent variable, they also have other names. These dependent variable and independent variable, they also have other names. That goes for my first question. I expect everyone to watch this video on the YouTube channel and write down the other names that you can call dependent variable and the other names that you can call independent variables. So you drop them down there so that we'll look at it. Independent variables and dependent variables have other names. They can also be called dash and dash. So let me see what you will have in the comment section. So we proceed to the next key section in this topic, which is types of models. There are various types of models. There are various types of model. You can start from the simple model, which is the verbal models. Number one, verbal models. It's a very simple one. Verbal models are just when you put relationship in a statement form. You put a relationship between uh, variables in a statement form. It is well known. By the time you say it shows mathematical relationship. It will be clear that is a mathematical relationship, but not in mathematical terms. For instance, when you say 2 raised to power 5, or you say x raised to power 2 equal to 3 or equal to 5, you have shown that this is a mathematical relationship, but it's a statement, it's a verbal model. Now, the second one is the algebraic or mathematical models, which is the most common and the most used and applied ones in everywhere in mathematics and so on, in economics. They are uh, they represent a set of mathematical equations describing the working of a system, particularly the economy. There are different kind of models in economics that are very useful. Then there is the programming model used by economic planners for optimization uh, issues and economic planning. For instance, there's what we call linear programming model. The linear programming model is used by um, economists for what we call optimization, particularly firms. When you to optimize is to get the best out of your resources or your input or whatever in your business. So you try to know what is the best mix of, for instance, capital and labor to give you the best output, you know, with the minimal cost. Remember, it's very important. A firm wants to minimize cost, so always note that. So whenever you see the business firm jumping up and down, consulting specialists and so on, what they just want to do is how to maximize profit by minimizing costs. So programming models become very, very relevant in that. Then there is the accounting models, which is designed for keeping record and updating financial information about the business. Then there's the physical model, which is used by engineers. The physical model, that's number 5, used by engineers, by uh, architects, and so on. Then this one is just like a summary of it, or like, okay, the economic models, which of course describes the working of an economy or a given system, in the economy. So these are just names, you understand. But generally, what you expect in models is that you are going to see some mathematical notations. You're going to see some mathematical notations, uh, some relationships. You understand? These are 6 types of model. Then we have the processes of modeling.